We're going to start with our product and quotient rules. We've got a couple of different rules that we're going to be using, and we'll do quick proofs and a couple of example problems for each of these. Here's a little refresher for you. We're going to be using this to prove the product rule. So using that limit definition of a derivative, if I took the product of f and g and derived it, I would get this statement. Now, here's something that you wouldn't have thought to do, but you just need to appreciate the fact that it's true. You'll notice in green, what was inserted in that derivative expression is minus that product of f of x times g of x plus h. But then, right here, we canceled it out by adding it again. Just appreciate that it's true, because it is. That for the first two terms, they both have a g of x plus h. So that got factored out, leaving them with f of x plus h minus f of x. That's here in red. For the second terms, you'll notice that they both have the f of x. That got factored out. And then that left us with g of x plus h minus g of x. So we wrote that last statement, put it right here. So then we go to the next part. Next part is just writing these as two separate fractions. So you notice that we just grouped these two terms in red together so that they created that red expression multiplied to their corresponding parts. That's this step here. And then we identified, don't forget, that limit as h approaches 0, that this is f prime of x. And this, as h approaches 0, is g prime. So we rewrote that last step right here. And then we look at what we can do with that g of x plus h. If my h is approaching 0, I can replace that with g of x. Whoops. And that then leaves us, folks, with what our product rule is. So we can also just abbreviate and write it like so. I want you to keep in mind, since addition is commutative, we could also just say that, so is multiplication, that the derivative of any function f times g could also be fg prime plus gf prime. They are all going to give us the same result. Now let's do the example for the first one. And you'll notice I put the derivative formula there. So let's just, for our purposes, identify and label both of those as independent functions f and g. So if I'm using my product rule, I would bring down my g function and multiply it by the derivative of f, which would be 2x. So that's gf prime plus, and now I bring down my f, which is x squared, and I take the derivative of g, which is 5x to the fourth. We simplify that, and that gives us 2x to the 6 plus 5x to the 6, which leaves us with 7x to the 6. And I would like you to keep in mind that we could have looked at this problem from the jump and said, before I clean that up, and then I derive. And our derivative of x to the 7th would also be 7x to the 6th. If we did this same process with problem 2, we would just define those two as separate functions, f and g, and then I would bring down x to the 4th and take the derivative of 6 to the x, which is 6 to the x times ln of 6. Plus, and now I bring down my f, which is 6 to the x, and derive x to the 4th, which is 4x cubed. So we can't really clean that up that much, but what we could do, we don't have to, is we could pull out the 6 to the x. That would give us x to the 4th ln 6 plus 4x cubed. But I would like to try a problem with you that gives us a table of values. So let's jump to problem 7, where they're asking us to find the derivative of the product of f times g of 2. So that would be, folks, the same as the derivative of the product of f and g when x is 2. So let's write down our product formula. So it's right there, and let's identify. In this problem, this is what we're looking for. G of 2, f prime of 2, plus f2, g prime of 2. So if we look at our table, these are the x values at 1 and 2. So g of 2 would be 5. The next value we want to find is, so we found that one, f prime of 2. So there's our 2 column, and f prime of 2 is 4. So 5 times 4 plus, and now we're looking for f of 2. And f of 2 is 6. Lastly, we want to multiply that to g prime of 2. And g prime of 2 is 8. So then we clean that up. Now let's prove our quotient rule. And we're actually going to use the product rule to do that. First, we're going to rewrite that q of x, and we know that our objective, we want to find q prime of x. The first thing you know is if q of x is f of x over g of x, then if we cross multiply, we would get that f of x equals the product of q times g. So what we're going to do now, folks, is we're going to take the derivative of this, and it would look like this. F prime is equal to q prime times g plus q times g prime. That's our product rule. And we keep in mind that what we want to get is this. So if we subtracted q of x, g prime of x from both sides, we would have f prime minus that equals q prime times g. So our next step would be to divide both sides by g, which would take us here, and then we could rewrite that as this. But we're not finished. Now we want to go back and remember what our q of x equaled. It equaled this. So we're going to replace q of x with that new expression. And so we get this. And then, so we could now write this all as f prime minus that 1 fraction times 1 over g of x. Our next step is we're going to distribute the g of x. And that would leave us with this. Now we just want to get one common fraction, so we're going to multiply that first fraction by g of x to the top and bottom, and that would leave us with this. So, knowing this, that tells us that the derivative of any quotient of two functions, f over g, is going to be g times f prime minus f times g prime all over g squared. If we were to abbreviate this, we would get this expression. And this, folks, is our quotient rule. There's something that some people find helpful in trying to remember this because the order in which we write this matters since it's subtraction. We refer to the top function, f, as the high function since it sits on top, and the low one as g. You get the idea because it's on the bottom. D we treat as the derivative, and there's a mnemonic device that says low D high, less high D low. Oh, I forgot to write the bottom. Over the square of what's below. What does that mean? It means we start with the low and we multiply by the D high. Low D high less high, which is the f function, D low. times the derivative of g, the bottom function, over the square of what's below. Let's do a warm-up by taking the derivative of this function. And until it's committed to memory, and it will be, I promise you, let's just write up our formula above. Lodi high less high d low, all over the square of the bottom. So here we go. So we'll start with the low, that's x to the fifth, that's our g. D high, taking the derivative of x to the eighth, less high, so we write the x to the eighth, d low, we take the derivative of the denominator, all over x to the fifth squared. And now we simplify, and we get this. Whoops. And then we clean that up, which would take us here, and then our last step would be to simplify. So that tells us that the derivative of x to the eighth over x to the fifth is 3x squared. And we knew that as well, just because that would have cleaned up to give us x cubed, and that. So let's do 5 as our practice. So here we start with low d high less high d low. So we bring our 3 to the y times the derivative of y to the eighth, 8y to the seventh, less. We bring down our f, our y to the eighth, high, and then we take the derivative of the bottom, d low, which is 3 to the y ln 3 all over 3 to the y squared. And now we clean up and we pull out what we can. And we noticed that both terms had a 3 to the y, and both terms had 7 y's in common. So we pulled out a y to the seventh, that's our common factor, and that left us with 8 minus y ln 3, and the denominator is now 3 to the 2y. So the last thing we can do is simplify our 3 to the y and 3 to the 2y. How can I simplify that? Well, 3 to the 2y is just 3 to the y times 3 to the y. So one of those cancels with the other, and that leaves us with our final answer. Now let's try one of the problems that requires our table of values. And if we look at 9, and 9's a little bit trippy because it's asking us for g over f, the derivative at 2. So now that our g's and f's have switched places, our derivative expression should look like this, because now the f is the low and the g is the high. So now we just replace these with all of the terms in our table. And we identify that we're looking at the 2 column, and we replace all of these with their respective values. So our expression looks like this. It simplifies to this, which takes us here and brings us home. So for problem 9, 7/9 is our answer.